Hello, hello, hello. Welcome to number 2 of P5 to VVVV. 4Vs, V4, how other people say. This time we're also going to do number 2 of the coding challenge from the amazing coding train. And what we're going to create this time is a Menja sponge fractal. So in the coding train example, every time you click, this circle gets split up in more circles. And if a certain relationship of the circles are true, we gonna not show these circles. So we leave certain circles out, and at some parts we gonna show some circles. Yeah, that's what we're gonna try to achieve today. Let's see how far we get. I see it already gets really slow after certain iterations. So we have one circle and then 2 clicks, 3 clicks, 4 clicks makes it already quite slow. So be careful. Because it is creating a lot of new circuits every time you click, and that makes it really expensive. Yeah, and we're going to try to use V4's advantage of some instancing and some optimization. It's going to be a little bit more advanced, but also some interesting concepts I think get shown. So I think it's worth it to show it, to do it. Let's go. So what I would start with is with the list of sponge. So we can double click, write sponge, and then create a pad. And the type is gonna be the name of our object. So we're also gonna call it a box. But what it mainly is the sponge is storing a lot of boxes, as you can see here. So we create variable b, which is a new box, and then we add that box to the sponge. So we have a spread of boxes in VVV, and for that we create our own data types. The box, but box is already used so much, so I would call it my box or sponge box. Yeah, sponge box. And we're gonna make it a record because every time we click, we actually not gonna use the boxes that got created before, which would make sense there to use a class. But we create a whole new amount of boxes. So we use a record. More to that, there is a lot of information between classes and records from VVV. Let's see. I think there is a tutorial. Difference between that's beta. I think there's a yes. Amazing tutorial. Whoop. From Toby K, which was super helpful, as you can see. My comment is here. Yeah, that was super helpful actually, also for this tutorial. So I want to say thank you to Toby K and to people from the VVVV V4 element chat, because they also helped me a little bit, or helped me with cracking this. But yeah, mainly the difference between records and classes is that classes, the can be changed while the program is running, and records can't be changed, but they get recreated. And because we want on every click want to recreate new boxes, we use a record. This is really dialed down. I just can recommend the other tutorial. So let's go into our sponge box. So we go into the box.js to see what they are creating there. And we can see already that we have kind of like a behavior on create when the box gets created, or similar to a constructor function, which is position and radius. So what we can do is, let's make an area, properties to make it really clear, and then we create position. And because there's already so much position there, maybe type it and then use a pad, then middle click to open the configure menu, and we want a vector 3. And to expose the input pin for when we create it, we can hold down control, and then we create a radius pad. Again, define it. This time we make it a float, and then we can expose it again. So we already have these two properties, which is good. And what I first want to do is kind of creating the basic functionality to add one box to the sponge, and create a counter to assure that we don't create too many boxes. Otherwise our code is gonna crash down, similar to what we saw here. Yeah, so first I would define this as a spread of sponge box. So we have our list, and then we want to create, because here we already create in our first setup, we create one box. So we also want to do that. We create an if region, make a bang, and add a talk edge. So we assure that this trigger only gets called once per frame. And we plug in the sponge, add of spread, and then we can use create, which is the constructor, or yeah, constructor, and then we look for sponge box, and we create our first box. We can create it with a radius of 1. But what I also want to add, and which helps a lot with debugging also, is we want to add the if region to clear the spread, so we can walk better through the steps and yeah, go back to 0 when we hit when the if region gets true. So this could be a bit more pretty. Let's make it straight. Yeah, do this, take these two, copy and paste them, plug them again. So if we would now just to restore it back into it, now we have 0 boxes. Sorry, we had some microphone problems, but we continue here. So yeah, now 0 boxes. And if I hit the second condition, I get 1. And if I click this one, I clear it out. This is just to, yeah, prototype better, try it out. So the next step is to avoid that too many times, or the next step is more to assure that this only gets executed once, because we're going to use the same trigger here for another logic, and I only want that this sponge box, the first one, gets added to the spread if the amount in the spread are not bigger than 0. So only on the first trigger I want to add 1. So what we're going to do is we take the output of the if region and we count how many elements are in the spread. This gives us an integer. So if I add, gives us more, or gives us the amount. And only if count is smaller than 1, I actually want to trigger this. So what I want is when I hit this, only if the amount of boxes in the spread are 0, create a new box. So we take an and we want this condition and that condition, and then we trigger this. So now what we have is, let's see. So we have 0 in there, and then if I hit it, 1 gets added. But if I click on it again, there will be none added after that, because then the count is, this condition is not true anymore, and with this end, both have to be true to trigger this. This is important because when we add the other boxes later, we don't want that this add box gets executed again. We only want to execute on the very first iteration. So because out of laziness, we're going to use the same trigger to count the steps that we already did, so we can safe proof that we don't click too many times and our system gets really slow. So what we're going to do is we take a counter, similar to resetting the whole spread. We also want to reset the counter, so we can call this reset also. And we call this step up. And what we're going to do now is we create a steps pad. We configure it as an integer. And then we gonna create an integer. Yeah, 32 actually. Sign this, and that's gonna be trouble because I picked the wrong integer. And now we assign this on the create, and what this does is when the whole application gets started, it assigns the value 0 to the steps pad. For example, take 6, it's 0 now, but if I go to application restart, we see that 6 got assigned. So we want to set that to 0, restart again, application restart, and then it's 0. So on start of the application, the value is 0. And we take this to set the default value for the counter. So every time the program starts, the counter gets reset it to 0, basically. So now we can take the same talk edge from here and plug it into the up. So every time we click here, the counter gets count up. And every time we hit reset, it's going to get count down. And if we hit reset, it's 0 again. So that was a bit long-wielded, but that was also important. So now it's getting really interesting. So what we want is we want to start to execute this behavior, which is here on mouse pressed. So every time the mouse is pressed, they create a new list, and they're going to generate for every element that is already in the sponge, they generate a new list of boxes. You can see that here. So for each element in the sponge, they assign the sponge to a variable b, and for that box they generate new boxes. Where you can see this is the generate function, and in that box they create a new list of boxes and go through 3 for loops to add new boxes to that box. And then at the end they return it and store it. So they return in the generate, they return that to new boxes, and then they store that to the list with concat, and this becomes the new list of sponges. So this becomes, they overwrite the old list with the new sponges. For the exact explanation, I would suggest actually look for the coding train coding challenge. I mean, he is the master of explaining these things. I try my best, but yeah, the focus here is more on translating it into VVV. And yeah, so what we want to do is, because we don't want we only want to add new boxes if the condition is true that the counter is smaller then our max steps value. This assures that only if we have done less steps than the max steps, we allow the whole generation of new boxes, which is happening in generate. Yeah, this is just a safety. So we again take an n and we want to use, is our counter smaller than max steps, and is the step up clicked? If that's true, so we use an if region, then execute that if region. Okay, so now we plug in the output of the first if into the input. So actually what happens in here also gets executed to and stored back to Sponge. And what we now want to do is we want to go one step further, and this time we don't want to use a spread to generate all these, because what we see here is for each box that we have, we're creating 27 new boxes, because we start from -1 till 1, which is -1, 0, 1, and this in four loops is going to create 27 new ones, because -1, 0, 1 is 3 elements. Whoa, is 3 elements, and that, if we see 3 times 3 times 3 equals 27. So what's really important here is that we gonna use things that are performant, and I think it never hurts to start with optimizing early enough. So long story short, what we're gonna do is, we, instead of using a spread, we're using a spread builder. What a spread builder does is basically create similar, something like a spread, but is not each time creating a new spread in the memory, but uses the same memory space but changes it in the location. It is really complicated. It is just more performant because it doesn't every time allocate new memory for the creation. So what we have to do for that is we start with a clear builder, clear spread builder, and from there we can just create our data type for this. They call it here var boxes. I would call it spread builder boxes, which is not doing what I want. So we just create a pad, call it spread builder boxes, because we couldn't find a longer. And what we then do is spread builder here, and we want it of type, what's it, sponge box, no? Exactly. So we basically created something similar than a spread of sponge boxes, but a more optimized version of it. And what we want to do next is we want to connect it with a clear, because it needs to, every time it is executed, it needs to get kind of cleared. And then we want to create a for loop, which then executes the generate function for each element that is inside the spread of Spongebox. So the outer spread. Because what we're going to do after this spread builder logic is we're going to convert it back into a spread of Spongebox, and then we have all the elements inside our initial sponge spread. So what we have to do is now a for each, because we want to execute it for each element. We plug in the spread builder to the accumulator, and we also want to plug in the spread of boxes into the splicer. And now we want to create our generate function, which we have here. So we go back inside the sponge box, and what we're going to do is we create a fun function. So first I would say we start with, because the boxes comes from the outside, that's what we created already. So we want to create these 3 for loops, in our case for each loops, and I can promise you it's going to get messy, but it's also powerful. So yeah, we put them into each other by holding down space. We can put them in there, and now we have these 3 loops, but we want to change the index of them. So instead of from 0, 1, 2, we want to go from -1 to 2. So what we can do is we take I, it is under, we have to activate advanced nodes, and then you have to kind of like scroll down, and there you find it. And what this does is it creates a spread, and you can define the start value and the amount of elements you want. So that's going to be from from -1 to 0 to 1, because we just have 3 elements. And we're going to use, first we're going to do something, we're going to create our own operation, which is called generate, and we assign this to the generate function. Let's see, does it, no, it doesn't show it yet, but it's going to be. And what we want to do is we want to plug this in each for each, because we have the same kind of iteration here. We want to do the same here. So we click on the splicer here, click on the splicer there, and the splicer in the last one. And yeah, so we have kind of like this part already. What we want to do next is we want to calculate the sum of x, y, and z. And here we get it from the iterations, because we have here x, y, z defined. What we want to do is we want to create, because what we do here is we calculate the sum, and then we check if the sum is bigger than 1. And if it's true, we create a new box and we calculate a new radius. But yeah, for that I would create a new node, which is check if sum bigger. We plug that in and we go inside there. And what we basically have here is we need the inputs from X, Y, Z. Or let's make it a bit faster. We take an apps node, duplicate it, Control L to align them, and then we add them together. So we're creating the sum. Let's see, but maybe let's plug in the type. So if this is bigger than, as we see here, if the sum is bigger than 1, and this should help us already. Integer here, yeah. This already, because these nodes are generic, they can work for multiple data types that were grayed out. But now we define one crucial data type, which is an integer 32, and now v4 knows what is the basic data type. And we basically output the result of the sum, and what we can do here now is we create the inputs for, and be careful that you rename them, otherwise you just have one input into the node. And let's navigate back to Spongebox, and there we have now our node, and can really nicely, let's move that to the side so we have a bit more. Now we can plug in the different XYZs. And this is a check. So we already did this check. If the sum is bigger, and only then we want to add new boxes with new positions and add them to the list, to this incoming thread builder. So if that's true, if that condition is true, what we have to do now is we also need the split operation, which is kind of a standard v4 operation, which allows us to extract from our objects the properties. So we click on the lower part of the pad, hold down Control, and mark these both, and then we have to assign them, and we create a new operation and call it split. And what we want to do is, if this is true, we split up. We can reference the own operation here from Spongebox. And what I would do is already create the input. Let's assign the generate. We also can do that later, but maybe it's not like this. So yeah, we plug in the objects that are already in the sponge, and we want to have the radius of it, because there you see this box X is the position of the current object. Here we see this position, so this is the position of the current object. We add a x and y and z value from the iterations and multiply this with a new radius. So what we're going to do is we take the position now we have the position of the object. We want to add this position, so this position for each we want to add with first we would do so sorry, before we add the z value, which comes from the for each loops and the iteration, we want to multiply these with the new radius. So we take the radius of the current object, divide it with 3. So we take the division, divide it with 3, and this we want to multiply scale in our case, because we just want to scale existing vector 3, and we create that vector 3 from the iterations. So we can also name that, I forgot about this, we can name that X, we can name that Y, we can name that Z, so it gets a little bit clearer. We have the calculation if they are bigger, but we also want to join them here, because these are X, Y, Z are like Z, Y, and what comes in here is kind of like this position X, Y, Z. And now we multiply, we multiply the X, Y, Z for each element with the new radius, which is calculated here. New radius is this behavior. And then you see each of them gets multiplied. So we multiply them and then add them to the O position of the box. And the only thing that we now have to do is we have to create that new box. We have all the values calculated. We create a new sponge box with the, let's expose this maybe and call this, well, can we, no. So this is the new radius and this is the new position. If I would write that right. New R in our case. This is new R. What we calculate here. Get a bit wobbly, but yeah. So we have already the necessary information for the new object, and what we want to do now is we basically want to add this to the spread builder boxes that we created here. So let me reference here the generate function, because this is going to make the assignment all a bit better. So for the sponge box, we reference the one that already there, because we want that position, and then we reference the spread builder. And we get a problem. Spread builder sponge box. Let me see, what's the problem there? Ah, wait, yeah. The problem is that we don't have any, because what we want to do, sorry, we want to add to a new spread builder, and what we want to add is this new sponge box. And now we create the input. I haven't created the input. And this now needs to go through the if, through the accumulator of the for each for each, and then as an input. And we call this spread builder input, and that is sponge box object. And then we plug this out and create an output, and everything looks beautiful. If we now go out again, because now we have the input for the spread builder, the other one was a different input, and this one needs to get. We now want to output the spread builder. So we want to take the spread builder, plug it in here. And then we have this. We just have to get converted into a to spread. So we go from spread builder to, as I said before, back to spread. Take the right output, which gives us the new spread. Then we connect this, and we are back in the spread space. All right, this is already quite a bit. Let's see, maybe we can test a little bit the functionality before we do the whole drawing and the other jazz. So currently we have 0 spreads, 0 sponge boxes. Now if I hit it, we create 20. And that means, because the 7 in the middle, like 1, yeah, that means the 7 that are inside of it get don't get drawn. And yeah, let's see if we can make it a bit more easier to understand, to see. So what we're going to do is, we now, for each sponge box, we want to draw it. And to make it a bit efficient, we're going to use instancing. But we first need to transform the values inside this, or we need to do some transformations to position the boxes properly. And for that, we're going to go back into our sponge box, and we create, let's take this, and we create a little box and call it generate. And what we're going to do next is we create a new method. We call it show, and make a little show. Let's make a show here. And what we need in show is, we need a radius, and we need the position. We can take them, assign them, not like this. Click on it, assign, still done. Let's see. Vector 3 join, because what we want to do is, now for the boxes that we draw, here it's just 1. But for the box that we draw, we need to create a vector 3. So for each XYZ, we want the same radius. We connect this, and then right click, assign show. And this gives us what we want. We combine this with a transform SRT. You can type in really fast SRT, and you already get what you want, 3D transform. And we want to set this for the scaling. So we create the scaling of the box, and then we can assign the position, for each object, or each box in our case. And we want to create a random color for each box as well. So we create a random from 2. Again, under the advanced nodes, you wouldn't see them random from 2 like this. So you click here on the advanced nodes, and then you see from 2. And then you can pick RGBA, and this creates random colors in a range. And we want from black to 0. And output it again. And be careful that you have the same operation. So we want this to be shown again. And what we also want is random. If you middle click, no, if you configure, right click configure it, we have a show apply. And this allows us kind of like a trigger to decide if the random continuously runs or just executes once. So what we want is we output that, and we can output the transformations, rand color, transformations, make it pretty. And now we have this operation, which we can go into the for each, double click show, and then we get the Spongebox one. And what we want here is, because we're using instancing, and for instancing, we basically, maybe we start at the end. And that's a bit, so we have a scene window. No, we first have to reference via Stripe because we haven't done any graphical yet. We reference via Stripe to be able to draw in 3D. Then we create a scene window, which pops up really nicely. And for 3D scene, we want a root scene where we can add our boxes, and we also want to add a light so we can see anything. We want an ambient light. We add it here, and now we don't see anything yet. But when we can add a stripe box, and voila, very beautiful here. And to render this effectively, also if you hit F2, you see your performance, which is useful. So to render this effectively, we want to do instancing. And to do instancing, we need an instancing spread component. And we need to convert this to from value be spread. No. Let's see. Oh yeah, sometimes it doesn't show them properly, but exactly. So we take instancing spread component, combine it with a from value, which is a spread version, and then connect it to components. And what this allows us now is to we basically create a new spread with the transformations for each element, and then we plug it into the instance transformations, and it applies the transformations to each instance, which is going to be a box. So let's plug in the sponge in there. The method needs obviously the reference to sponge. And now what we do is we create a new spread with plugging in the output for each box into the splicer. And now we can connect this. And what we also want to do is to create random colors. First, we want to switch the apply, and we create another one, click on splicer, and this time we use a color per instance, so we can set for each color, for each box a different color, and we apply a PBR material, set it to material, and now we can use this to apply that, and we already have this. So we already can see the holes. If we start this, we don't have this case, but we already have this case. Oof. Yeah. And if I click one more time, like similar to, let me, if I now click one more time, I have the same split up like here. That's already fun, no? Beautiful. And I think if I click apply, we create some random values, but let's see why this. That's interesting. But yeah, we already have kind of like the same behavior. And if I now click one more time, it's going to be interesting. But yeah, we have our sponge. That's already kind of cool, no? And we obviously, yeah, we can put different lights, can move them. We can also, if you, for example, they are rotating it. So if you want to rotate all the boxes at the same time, if you would like to rotate every single box randomly or individually, you would need to go into the show and create kind of like a random rotation value here with random from 2. That's what you could do. But if you want similar rotation to the example from CodingTrain, you take again a transform SRT 3D, plug it in there, and now we can do, let's do a simple Wanderer 3D, just for example. Whoa, that's fast. Speed is weirdly fast always. Right click, configure, and make the precision a bit higher. Yeah, and then we can create something like that, for example. There you can also translate it, or you obviously can create a camera with orbit camera, plug it in there, and there we can play with the yarn. We also can change the distance. So you could, what we can do, for example, is let's do that. Take a LFO. And this is too crazy. So what we do is, because this value goes from 0 to 1, we create sine wave value. This is already, whoa, really fast. Let's make period a bit slower. And that's already cool because you can like dive into it. And to make the range a bit better, we go to map and we look, it goes from -1 to 1. So now the whole patching gets a little bit messier because I'm completely improvising and make it a bit faster. So I want to go from 0 to -5 maybe. And yeah, there's obviously now a lot of playground, and we can reset it obviously. So now we have like one box, and if we click step up, we split it up, and we can split it as till the max value. And yeah, there's one cool hack. It's not a hack, but one cool thing that I found, and what makes a fun effect is if we take the metalness up. So this is now going to be really trippy. So everybody who, it's a trigger warning, everybody who gets a bit can't really, shouldn't see like splashing values. I don't know the name, but everybody who can't see stroboscopic values should be aware. But this is already really interesting. You know, if you change the alpha blending, you can create kind of cool effects. But I really liked if you exaggerate the alpha to 100 and it's getting trippy. So you kind of like get a cool patterns, more effect, and especially if you raise the next step and then you go a bit closer or you go inside, that gets really good. You like half inside, beautiful. One fast thing, because I always want to advocate to why we're using VVV instead of P5, for example. So this is already obviously performance wise. This is really slow. This is faster. So it gets really slow when it has to create the new objects, but it works quite good like this. 60 frames is not bad. And to make it even give it more reason, we can convert this into a texture. Close this. Create a texture window. Make it beautiful again. I will close this for now. And yeah, just really quick. We can do RGB. Oh no, I first have to reference vl.stride.textureFX to get all the cool effects. And just to have a quick one is we obviously can do Shift RGB. I think I showed that last time as well. This is already fun. I mean, yeah. We also can create a simple feedback effect. That's probably nice. So we blend this. We create feedback node. Use this as well. Then plug the output of it back in it again. And this is already getting interesting because we have average. And if you now go threshold, that's dangerous. Yeah, we can create interesting feedback effect, and I'm not even plugging this in. Yeah, that's interesting. So yeah, all the black parts here, they now create this fun effect. RGB, where are you? Shift RGB, and then you already have a little trippy the effect. Or if you don't like this, you also can do this, which is also really cool. Like that. This is it. This is it. Very long one, I'm sorry. But a lot of concepts in here. We have instancing, which is super powerful to draw a lot of same shapes. And we learned how to create for each instance on color. We learned how to create these more performant 3 for each loops inside generate, which is here. Yeah, I hope it helped somebody, and thank you for watching.